Well, I'm gonna show some effects of SOF filtering on pre-stack data, and then that brought the motivation to have the flexibility of having a calculator, a simple calculator within ASPI, so we can always do subtraction additions. I mean, we are trying to encourage our users to stay as much as possible in ASPI, right? So if you bring an AVO product, let's say intercept and gradient, now we cannot do intercept times gradient, right? We will have to compute somewhere else. But with the calculator we're developing, and I'm working on the with the help of David and Dan, with the graphical user interface, you will be able to stay a little bit more longer in ASPI. So the motivation is three simple questions. Is post migration filtering? Yes, it enhances the frequency, the amplitudes, the clarity of the figure or the seismic imaging. But how does it deals with relative amplitudes, which might be important, especially when we are dealing with amplitude dependent prospects or areas of opportunities. And then a little bit more on the finding the box on the SOF. Is this filter friendly in amplitudes or regarding the amplitudes? I don't know if you remember Dr. Marford early this morning saying that every filter has its pitfall, right? And some people love to find pitfalls. I am one of those guys who it's always picking on the negative or where it might fail. Um, During Christmas, we were putting the Christmas tree, and I told to my wife, that ornament is not sitting well. I was sent to bed without supper, but I found the spot, and look better, in my opinion. Anyway, so I believe, and this is up to debate, that we ought to separate seismic data. I reckon that it's not something we can have. The abundance of a space or computational space, but fit to purpose data helps interpret to evaluate prospects, right? That's my motivation. So I'm not going to assume that everyone here knows what pre-stack data is. So let's call it a gather, a family of traces that are collected in an offset. Later on, thanks to the magic of mathematics and geophysics, they are transformed to angle domain. Uh, so you have angle gathers or offset gathers. And we have seen throughout the history of the amplitude prospecting that some prospect, when they have gas or when they have hydrocarbons, they may show flat spot or direct hydrocarbon indicators, DHIs. In early or mid July last year, or sorry, no, 2022, we showed that applying SOF, on a flat spot, it might take away a little bit of the flat spot character. And this is a post stack data from offshore Santa Barbara in the Pacific coast. It's a gas. It's a gas field. Well, it's not that big of a deal. The anomaly is small, but when you are talking about large areas and you are trying to de-risk the prospect, the idea of the flat spot being removed or tampered isn't something that you might want to consider. Then a friendly refresh on SOF, a structurally oriented filter. It scans the correlations or the similarities along the dip and tries to find the best similarities in that dip. So that brings us to the first pitfall. Sometimes even we have recording as like noise-free recording, the pure physics of the phenomena. If there are gas or any anomaly or hydrocarbons, there will be some deflections on the dip, especially on the gathers or on the arrivals times, and that dip might be overlooked by SOF. So Boschang in 2016 they implemented SOF on the pre-stack data, and one of the first steps is that you have to mute to assure that you are keeping all only information that you trust. You run the SOF, and then the sorry, the information that remain looks like it's only noise, right? But when you stack this noise, I will show you that there are some evidences of geological information that you may want to reconsider when you're removing it or not. Um, just a quick reminder of the workflow of SOF in pre-stack data. You load the data, you stack it first, you define your mutes first, sorry. Then you stack it, calculate the geometrical attributes and the similarities. So now you have the inline and crossline deep, and filter the deep components, and then you select the SOF that that best represent the your filter, or that you want to filter, right? And then you stop, or you can continue. So it's something that can be run iteratively. So, and that's something nice about SOF, that you can run it again. So on the left side, I'm showing now the first example, and with these three examples, I will try to at least make you think about how often, or how much filtering you want to do on your amplitude prospects. This is onshore, somewhere in the world. There is an AVO anomaly, roughly a class 3 top and base, orange and blue. And this is this line. This is a gathering this and this area, and this is around this prospect. This is a stack sandstones. So this is without SOF, and this is with SOF. So the data looks better defined, cleaner. The reflectivities along the gathers look stronger and more consistent. However, I like my amplitudes as pristine as possible. We can see that the AVO effect, the AVO curve, has changed a little bit, and this is sorry, I just realized I mixed the colors, but this is base still. Now, instead of having a strong AVO3, we have a soft AVO2, and maybe or soft 3. So I believe we can at this point we can make the decision whether we want to do our amplitude anomalies on the gathers, or our amplitude analysis on the gathers without SOF, and then we can do another stack just for interpreters to get a consistent and clean look on the prospect, right? So I don't know. It's one thing that I've been considering.
So are you saying the polarity has fixed this swap?
No. This is it was a mistake on my plotting, but the polarity hasn't changed, but the shape of the curve, yes. You see, it is smooth. Yes. Whether in this before SOF, it was trying to go to the maximum negative amplitude, right? Is the progress to the same, right? Well, we can debate a little bit about this. There are some well logs associated with this, and the rock physics modeling will show that there is a strong AVO class 3. And here, if we go to if we want to be nitty-gritty, we can say that now it's not going all the way down, but rather staying flat. So it could be a
So
2.
your bin size, is your bin size every 500 meters?
Uh, no, I think on the manual says to keep it twice the bin size.
sorry, the offset in your output,
Yeah.
500 meters?
No, here it's 100 meters. Yeah. Yeah, it's a fairly new data, not that sparse. Yes, for sure. This is another one here, another prospect that has a that has a gas effect and an oil effect. We see as an IBO still class 2, 2N3, and then when we apply SOF, the data it's cleaner, but then this is something that uh that made me think about should we keep two datas, one without SOF on the pre-stack when
Why is the stack image?
I think it's only the position maybe. Um yeah, it's the line should be here, but yeah.
Looking at different spots, right?
It just shifted. Yeah, it's the same in line, but a little bit shifted, yes. Yes?
Could you comment on the radius that you used for the structural filtering, or in general, like how harsh was how aggressive was the parameterization?
It was I followed the manual. It was twice the beam size. So in my case, I used 200 meters.
I don't know, person might weigh in here, but my experience on migrated stack data onshore, the structural oriented filtering actually is pretty gentle.
Yes.
Doing much, but I also the gatherers input gathering is pretty. So that's quite.
Well, yeah, the gathers are no issue for sure. And now the next example is going to be an offshore gather, hopefully cleaner. Um, this is this line somewhere in the world contains the classical game of three options. Who would you kill, date, and marry? So we have three options on prospects, uh, find oil, and struck wet. So I think here we have a nice BSR. Hopefully we see it the same. So here the gather, it's with a better frequency content, more balance, it's cleaner. These dippings are removed. I don't know if we agree with that. The continuity of the gathers are consistent. Yes.
What domain are you running the SOF in? Are you running it in common CDP or are you running it in common offset?
This is in common offset.
So are you using what kind of filter?
The principal component, the KL.
So the one issue that might occur with the KL filter at the farther offsets is you have a migration stretch effect that so you have a certain percentage of the wavelet in at the near offsets in a fixed window, and then you're seeing less and less of that wavelet farther offset.
Yes.
That'd be interesting to track down.
The wavelet stretch, right?
My thought, of course, I haven't looked at data this good, right? The data I always tend to have is like Kirchhoff migration. And that has a lot of noise in it. So I find the principal component doesn't work with noise burst. But the LUM and the aperture mean, they're a little more robust. So I'd suggest two things. One, when you're just looking at the offset, you can run the filter just on offset just to see what's going on. okay, without the evasive. And then once you figure that out, see if there's a difference between mean filter, median filter, principal component. My suspicion is, I have two hypotheses. One, it's a principal component thing. Two, there's a bug in the code that somebody has to fix. That's probably. I don't think that should happen. Can you?
Yes, of course.
Because some of what Kurt's talking about is stretch, but it looks like this is doing a pretty good job of taking it out. I mean, I'm not saying it necessarily. Because if you just go back before the filter, because some of these I start to see a little stretch.
Yes.
And I don't know what's that, because, and then you get.
But-
then if you have a constant timer depth where you're extracting,
Yeah, it's along the maximum peak or trough.
Yeah, or if you're saying you have more, there's more move out and farther offset.
it doesn't necessarily say move out, I mean, it's pretty flat, but you get a, like you said.
A wavelet stretch.
I call it the animal stretch. For
Yeah.
horizontal data, you see this all the time. That's
Sure.
the first order.
Right.
You'll never get away.
No, it's just, but then if you look after from the.
Yeah.
You pretty much, so,
And the offset, in the offset domain, we're asking the filter is flat.
so I'm
So
wondering,
it's clobbering that stuff that.
it's maybe one thing to look at, right?
Yeah.
Because of that stretch, if you have something that's flat with time cross offset. Like. I'm not sure that's exactly, I don't think that's the only thing going on here. I think that might, at least some part of the soup, one of the ingredients of the soup.
But one thing that we perhaps we can agree is that we are adding more ingredients into the soup. And at some point, you might consider if you want to drink it or not.
Well, yeah, when I meant by soup, it's things that I put around change.
Yeah, so in this case, I don't have the boreholes to do any rock physics and have a synthetic gather. On the other two I do. But I think it makes a great job on removing these dipping effects here, for example. Right?
Yeah, that's either like.
And then I agree there is a focusing on this on the far offsets that it could be good for interpretation for generating an image, but the trend, if we go back to the ABO plots.
I mean, yeah, if you are.
So the trend here, you will be like, could this be maybe a class 3 or class 2? Trying to go negative, right? And then after SOF, it is just like, okay, there is no reflectivity change or there is little. So that's something that, for example, for a rock physicist or someone who does inversion will be like something to question, right? But I think it, like, I even think that SOF does better job cleaning the data pre-stacked than once already stacked. And perhaps adding the spectral balance that Pamela was showing, it will make a more robust workflow. And I would add, try the wavelet stretching, that it's also in AASPI. Try to have a more robust filtering strategy. Yes, please.
How often is the pre-stack SOF being used? Is it something folks are doing routinely, or is this a special effort? I just.
Yeah, that's a great question. We want a lot of people to use it, so we are showing it.
But has it been used a lot? I'm going back to Kurt's. Hypothesis that maybe there's a bug.
Yeah, so Well, we've used this quite a bit and, in data from Mexico, Basin. I think maybe one thing to show, because this is the next part of your talk, you're gonna show some different things. Do
Yes.
you have what you threw away for the gather and offset, the other picture of that?
No, just on the stack. I stacked the noise.
It's interesting to see what you
That would
threw
be,
away.
that would be very, yes.
Yeah, what you threw away in CMP gather mode and also in offset by offset.
Yeah.
As well as when you threw away different plot and stacks, all three of those domains will be spread.
Yes, and I should have built that. I only from the rejected noise from each CDP, I stacked the CDPs, and here is some of what came out. So there is a lot of we were looking at the gather somewhere here, but there's somehow information, right, that it's still left out from the rejected noise on the CDPs. It does a great job on the bottom, right? There are, I think, I'm trying to use Dr. Marford's code for arrows, areas of opportunities, good and bad. So I think there are some questionings regarding these two areas. We were looking at the gather right here at this position. So the noise is stacked. The rejected at CDP is stacked.
There's a lot.
And look at this in common offset by common offset. Is it coming from farther offset or?
I think it's coming from further offset, but yeah, that's a good test.
Change the parameter from this. I think that was the worst. I'm too at least surprised. I think from what I've seen on the algorithm on post-stack data, it's very gentle. And I'm pretty motivated to stay firm. Just a thought, back to Kurt's hypothesis that maybe there's a what would happen if you made a simple synthetic using your convolutional algorithm or something? No APO,
Yeah.
noise free, totally noise free. And you just push that data through. It should be a
Yes, it should be 0, 0. Yeah, we can do that. We have a couple of synthetic gathers.
You could probably do.
a little bit in there.
Stretch, how much of stretch, which would be,
Yeah, that's a very good point.
so you can test all these things.
Yes. But the last thing I'll say is just from a processing perspective, that amount of I call
Signal.
leakage,
Yeah.
signal that's on that noise spot is way higher than what sort of state of the art size of the process. Yeah. Despite that, I think this structuring filtering is a good algorithm. So I'm kind of to this.
Yes, I agree.
Are you clever enough?
Not
Take
to-
this picture and then the stack after SOF signal and animate between the two. And if we have residual move out and the far offsets, that water bottom reflector should be down. And that would answer some of the questions. You see what I'm saying?
Yeah.
Yeah.
I can do the test. Yes. Yes.
Going back to my process, and another thing we did, we actually did pre-stack, the post-migration cleanup, we did pre-stack SOFs in common offset a lot. And one thing we did is you do a 0 to 1 taper in the angular gather domain for this model. So you preserve the far offsets. You
Uh-huh.
don't really do this in linear offsets. You don't want to snack any of that. Go back to the observer view. So you do common offset SOF, and then you have that node model taper to the. You don't have it applied when you're down for snacking.
So do you see the same kind of effect?
Yeah, it's really, but it's really nice. You see those like, a lot of these like, in CDP domain, you'll see all these like. Sometimes, but
So you taper the near offsets, and then Or
you don't apply the SOF to the far offsets, and you have
Yes.
to go from like, depends on like, it means if you really want really, really clean your offset, in your stack, right, and you kind of like in your mid and far angle stacks, you kind of start tapering that, the aggressiveness of the noise
Yes.
to zero.
This stuff is done offset plane by offset, right? Offset, have I got that right?
yes,
Why are we caring so much about the stretch effect? I mean, the stretch is essentially more or less an offset consistent comment, right? At per given time level. So
Yeah.
why are we worried?
Well, no, it's not done
No.
offset by offset.
It's not?
It's done by default unless you do something different.
no, it's
You're gonna do a 3 by 3 by 3,
Striding with domains.
three inlines, 3 cross lines, 3 offset, around the center offset. Now you can change it just by 3 offset.
Right.
Or not.
Yeah, like your mouse offset.
And the first vice versa.
Okay.
Yeah.
You're thinking that the offset stride, mixing the offsets are notional far offsets, stretch. Yeah.
I mean, it was, I just thought maybe something. Before you had stretch and have. I don't know, if it may not to it, like, you know, the. Hurting, but, no, the simplest is better. From a flat, where you can put in and take it and not stretch.
yeah, I think that would be enough.
So if I remember correctly, so when the air turbine, we apply the air turbine. I think the offset is offset, all right? So.
You're asking him, right?
No, you.
He said Kurt before, he started getting.
I think they they're very also
Yeah.
Yeah.
Yeah, the 3 by 3 by 3.
Yes, but the east, we, that's what we organize, we organize not appreciate, also, but also.
We can do it there's all kinds of possibilities. We can do it cross offset and avenue and inline and cross line.
Yeah.
Make it as big as you want. So, but I think, what's good is, Alex has got a new part, another pitfall entry for my book with Chopra. So, thank you.
Yes, and yeah, that's a summary. There could be pitfalls. And for you guys to give us data to try, that's a great way to start. So we have pre-stack gathers to mess around. It's not that they are abundant. But yeah, I leave it with that. Thank you for the candid discussion. Good questions and great interaction. Thank you.